Okay, this is our first lecture on section 4.4, solving linear equations in one variable. Our objectives in this section are solving linear equations by simplifying, learning to clear an equation of fractions and decimal or decimals, and the three types of equations. Lehman will also go into a few more topics that I'm not going to cover further at this time, translation, graphing to solve, and locating errors. We've already covered translation, we've already covered graphing to solve, and locating errors is just a matter of places that you need to look in order to make sure that you haven't made any errors. You should go over that in Lehman's text. Okay, so solving equations algebraically, the first thing that we want to do is to distribute. Then if necessary, we would need to clear the equation of fractions or decimals. We'll do that in a little bit. Then we would need to simplify each side of the equation by combining like terms. And then we would need to apply the addition property to move variables to the left or to the right, depends upon which side you want to move them to, and move the constants to the other side, again by applying this addition property. And then we need to remove the numeric coefficient by applying the multiplication property. And finally, we write the solution as a set using rosters, or we say the variable equals the number. My preference is a variable equals a number. So with that said, let's go ahead and take a look at example number 23 here. So on example number 23a, we have an application of both the addition property and the multiplication property. So our first is to get all of our constants together. So we see a plus a negative 2 here. So we're going to add its opposite. So we're going to add a positive 2, not just to the left side, but also to the right side. And now we have 14x on the left, negative 2 and positive 2 equals 0. And so we don't write it, 26 plus 2, which is equal to 28. And now we apply the multiplication property of equality. So we're going to multiply by the reciprocal of the numeric coefficient. The numeric coefficient is 14, so multiplying by the reciprocal of 14. And keeping in mind that multiplication by the reciprocal looks like division. And so what we are going to end up with is that x is equal to 28 divided by 14, which is equal to 2. Do keep in mind that even if you do not know 28 is divided by 14 is equal to 2, you can use canceling because 28 and 14 are both divisible by 7, so you take those factors of 7 out, and then you'll see that the remaining numbers, which would be 4 and 2, would give you a quotient of 2. All right, moving on to our next example here, we have, this one was actually a mistake. Let me fix that really quickly. So we have the 12x minus 6 is equal to 8x plus 14. So first of all, we want to get all of our variables on one side. So this 8x I'm going to bring over here with the 12x. Wherever we have the larger numeric coefficient is where we want to take our variables. So I'm going to add the opposite here of negative 8x to both sides. And when I add the negative 8x to both sides, now I'm going to create another equivalent equation, and so this time I have 12x minus 8x, which is equal to 4x, and then plus a negative 6, and that's equal to a positive 14. And then finally, this constant, negative 6x, needs to go over to the right to be with the other constants, so I'll add its opposite, positive 6, to both sides. And now from there, I have 4x is equal to 14 plus 6, which is equal to 20. And now, finally, once I have that, then I'm going to use the multiplication property of equality. So I'll multiply both sides by the numeric coefficient of x, which is 1/4. On the right-hand side here, I'll show it looking like division, since that's what it is. And finally, I'm going to find that x is equal to 20, or is equal to 20. No, it's equal to 5. And so that'll be my final solution. And of course, that will wrap up the use of both the addition property and the multiplication property. First, we only use the addition property once. Second, we use the addition property twice. And in both cases, we use the multiplication property. Now in our next step, our next type of equations, we're going to be using both distributive properties and simplifying properties in order to simplify these algebraic expressions on the left and the right, and then to solve the equations.